Another concept in elective mathematics is composition of functions. That's another operation that is done on functions uh, in a certain way. So most people get confused with that, especially with multiplication. So this in this session, we want to actually understand the composition of functions. So from the name, right, composition. So you can see composition as um, something, a function containing another function. A function is composed of another function. So function one composes function B, meaning that function one composed of function two, or you can see that function one contains function two. That's the basic thing about it. So you just basically, instead of putting a variable inside a function, right, you now put a whole function inside another function. Let me illustrate that with an example. So on this board, we have this, right? Let me actually go to a blank board. So we have a blank board, then we have our usual thing, f of x is equal to 3x minus 4. You see that in things like this, the over here we have the input variable x. So we only put an input variable inside the function as our input, right? And then we have the full expression over here. Okay. But in composition of functions, what we are doing is that we are not just putting an input variable. We are not taking a variable and putting it inside the function, but we are going to take a whole new function, a whole different function, and put it inside this function and do operations on it. That's basically what composition of function is. So we are basically going to remove this input variable. Instead of being a variable, it's now going to be a function. So if I have function one is f of x, right? And then function two is another f of x. So what will happen is that for me to have the function one composed of function two is going to be function one going to contain function two. You see what happens? At the place of the input variable for function one, I'm now putting um, a whole function f of 2 there instead of it being just a variable. So the function 1 is going to contain function 2. How we usually illustrate that, or how we usually write that, is f1 is o f2. When you see this o, it's not multiplication. So in the books, right, when they are typing, it's actually very small. So f1 small o, then f2 is different from f1 dot f2. This is multiplication. This one is multiplication, but this one is composition. This one is composition. Take note of that. So when they give you a function like this, they say find f1 o f2. O is composition, so f1 composites function f2. So basically, what is telling you in plain English term is that function one should contain this function one should contain function two, meaning we are putting this function two inside function one. How do we put that inside function one? By changing the input variable of the function one, which is x, and putting a whole new function two inside. Don't worry, let's solve some examples so that you can actually understand. So over here we have two examples, right? F of x is equal to 2s and g of s is equal to s squared. So the question says we should find f o g of x. So what does this mean? The o means composite, right? F should contain g. So at the place of x, x of for f of x, we are just going to put the whole g here. G is g of x, right? We are going to put the whole here. So what does it mean? The input variable now is g of x. So here, when it was x, right, you see you have the s expression here, and this is where x is located. Now at the place of x, we are replacing the f of x with a whole of g of x. So what we are basically going to do is that wherever you see x in the operation, like this place, wherever you see x in the operation, we are going to replace it with g of x. That's all. So how do we do that? So it's going to be 2. We are supposed to write x here, but we are not going to write x because we have changed it to, in the input variable is no more x, but it's actually g of s. It's going to be 2g of x. But then what's the expression for g of x? The expression for g of s is s squared. So you go and replace that and write 2 g of s stand contains what is actually s squared. So we are going to write s squared here. So this is f of g of x. So f now contains g of x. Another way of writing is f g this is equal to 2s squared. As simple as that, right? Let's do the other way and see if you get that illustration. I'm going to do the reverse, where I will do G O F. So it's going to be G O F of X. So meaning that G should now contain F. So we are going to put F inside G. So it's going to be, it can also be written as F of X at the input variable of this. So instead of X, right, we are going to put F there. But then, so the expression for G is what? S squared. Right, but at the place of S squared, we are going to put what? F of X there. So it's going to be F of X all squared. But now what's the expression for S? F of S. F of S is what? 2x, right? So it's going to be 2x all squared. So if you expand this, you are going to have 4s squared. So G of F of X is equal to 4s squared. You see that? This is how to actually simplify this particular thing given us. Okay, so let's look at another example. Here, they are just simple functions, g of s, s of s. So let's actually move a little further and then see if we have a function like this. Now we have g of f of s and others, right? I'm going to have to do f of g of x. This is what we are asked to do. So how do I do that? Um, so this one means that we are going to put g of x inside f of s, right? So I'm going to do like this. So you see something like this, f of g of x. What's that? So g of s. So g of s, wherever you see the x inside the f, right? You put the whole of g of s there. So it's going to be 2 times g of x. Why? Because g of s is now the input. It is replacing the x. That's what it basically means. F was initially having x as its input variable, but now you replace it with g of x. So wherever you see x inside the expression for f, you just put the whole of g, right? Minus 1. So but then we know that our g of s is this thing, So we just replace. So just like locating the thing and putting it at the right places, and then you expand. That's what. So in this minus 1 here, so we have here, so remember this whole thing is a g of s that we got from there. Okay, so now if you expand this one, we just basically do simple expansion. Minus 4x plus 2 minus 1. Then if you simplify this, that we're going to have, so f of g of x will now be equal to 2s squared minus 4x plus 1. So this is the final answer for this particular um, expression. Okay, so now there's something nice about this. Sometimes they will ask you not to find f of g of x, but then they will ask you to find something like f of g of 1, for example. They will actually put a number there. They will actually put a number there, right? So what you can do is that there are two ways of doing this. So the first way is to make sure that you actually consider it as f of g of x first. You remove the 1, you put s of s as a variable there. Then you do this expansion that we got, like you do the same thing. And when you come here, you finally get here, you now replace the x with 1. So now you're now going to have f of g of 1 is going to be equal to 1 squared. You replace the s with 1, right? Times 1 plus 1. So then you do this, you're going to have 2 minus 4 plus 1, and it's going to give you negative 1. So this is the final answer for f of g of 1. Okay, so yeah, so just replace the variable with that. The other way of doing that is, they say we should find f of g of 1, right? So basically, uh, we had our f of x to be equal to 2x minus 1, yes. And then g of x was s squared minus 2x plus 1. And they are asking us to find f of g of 1. So in this case, I can decide to go and find f of g of 1 first, because this one can be written as f of this one like this, 1, right? You can decide to find f of g of 1, where you just put 1 inside g of. So you can find g of 1 first. If I find a g of 1, I'm going to have 1 squared minus 2 times 1 plus 1. So if you do that, you are going to have 1 minus 2 plus 1. And we are getting what? zero basically. So now that we got zero, right? Now we put this zero, so we put it inside here. So we become, now we now find f of zero, because zero is now our g of f, because g of s of 1 has given us zero, and to f of zero is going to be 2 multiplying zero minus 1. So what do I have? 2 times 0 is 0 minus 1. So it's equal to negative 1, like how we got it from the previous one. So these are the two ways of proving that if they are giving you a number. And I think if this is simple, if they give you a number already directly, don't bother yourself trying to go the long method, right? But I believe showing the method after finding a g of s, I think it will fetch you more marks. But then, based on how your marking scheme goes, right? To master the two so that the one that is faster for you, just go with that. I think this one is quite fast. So where you find g of 1 first, inside that, then you put it inside the other one, then you get the same answer. So composition of function, basically, or to put one function inside the other. Rewatch the video if some you are confused at a point, and put it in the comment section so that we can attend to you and solve more examples so that you can solidify this concept.